I'm sure this panel is going to perk you right up. So may I invite our panelists to come to the stage? And our panel today is Accelerating Biomanufacturing Translation, the Role of Universities Beyond the Lab. I'm Huiling, and I'm the Consortium Manager for the Singapore Consortium for Synthetic Biology, and I'll be the moderator for this panel. So thank you for joining us to explore how universities can help biomanufacturing innovation cross from the benchtop to pilot scale and into the real world. So for our panelists today, I'll pass the time to each one of them to introduce themselves. First, we have Professor Won-Jae Choi.
Hello, good afternoon. I'm Won-Jae Choi from Singapore Institute of Technology. I'm working intensively on bioprocess development and downstream processing. I would like to share my thought depending on the questions. Yeah. Thank you very much.
So Prof. Choi brings together 20 years of developing industrial microbial strains, enzymes, and bioprocesses. Next, we have JD Lee, Mr. JD Lee, to share and introduce yourself.
Yes, hi, my name is JD. I am a part of NUS Enterprise, and we are also helping with the National Grid Program, where we help researchers think about commercialization and guide them through the entire journey. So really happy to be here.
Yes, JD is also a seasoned entrepreneur with multiple tech ventures, and it helps him to steer strategic initiatives in NUS. Next, we have Mr. Raymond Wu.
Hello, good afternoon. My name is Raymond Wu. I'm a Singapore office representative of Kyoto University and its VC arm called Kyoto iCAP, short for Kyoto University Innovation Capital. So our mandate is to commercialize university research in Kyoto University and across Japan. Personally, I'm an investor. I'm on the investment side of things, so we're really happy to see all of you here. Thank you.
So it's very exciting that our panelists today, they range from experience across academia, industry, as well as investment for this topic. So let's begin by aligning what do we mean by beyond the lab. We often say that universities should go beyond the lab, but in your view, what does beyond the lab mean in the context of biomanufacturing? So maybe I'll just invite Prof. Choi to share what does beyond the lab mean.
Okay. So I think the beyond the lab is to fill the gap between scientific discovery and industrial production. So in many innovations work at lab scale, few liter scale, lab scale operations, but there are huge demand from industry that they want to validate those kind of scientific proof of concept in a larger scale, which is closer to potential commercialization. So I think the beyond the lab is we need to include those kind of translational research in biotech.
Thanks, Prof. Choi. JD?
Yeah, I would say, referring back to the GRID program that I'm part of, we often talk about market validation as the very first step of our program. And beyond the market validation, then it's about thinking through things like the business model and how they actually frame their technology to investors. So I think these are very key components of what would be beyond the lab, at least from my point of view.
Thank you. So between lab and industry, there are many steps which need a lot of capital, a lot of effort, blood, sweat, and tears across many years. So I'm being on the more early sort of investment side of things. As the professor mentioned, translational research. JD also said market validation. These are very important. You frame it in a way, you ask certain key questions. Investors always ask key questions before making decisions. So what's the problem you're trying to solve? How do you solve it? Is there what's the scalability like? Is it realistic for investors to get back their returns, and etc. So we have the framework. Then upon the framework, you build on questions, and with bearing in mind that it will take a lot of time, effort, and capital.
Thanks for sharing. So now we have this shared understanding of what beyond the lab means. So going beyond lab innovation, lab optimization, it goes into going into a pilot scale, translation, looking at industry needs, and also capital to fund all this. So I think that really frames the three areas that we're looking at, which is the technical side, the talent side, and the commercial side, and also the capital. So maybe we just start with the infrastructure. What is one of the key bottlenecks in development or scale up? Why is it that innovation often stops in the university at the lab? Maybe I'll begin with Prof. Choi to give your take on this.
Yeah, very good question, I think. So many scientists, in our boundary, in our sector, there are two groups, scientists and engineer. So scientists is very much focused on scientific proof of concept, which is take place in their lab, few liter scale lab. But you know, if you look at the biotech, industrial biotech, we are handling living creatures, microorganisms, and their behavior is totally different, typically depending on the environmental condition. So lab scale achievement never be identical to large scale output. So it's totally different. That means you need to verify whatever you achieve in the lab scale in the larger scale facility to see whether it is working or not. That is one thing. And another point is our potential customer, which is industry players. It's very hard for them to believe what happened in the lab scale. So we have to provide certain tangible outcome, which is prototype sample. Yeah? So in order to prepare the prototype sample and validate your scientific proof of concept in the lab scale, we will need the pilot scale infrastructure to do that. So that is something we have to secure in between the science and the engineering. Yeah.
Maybe I'll add
yes.
Perspective from National Grid. So before it became National Grid, GRIP was a NUS-focused program, and we were helping teams for about 6 years. We have seen about 126 different incorporated startups during this time. And one of the key recurring themes that we see across all these startups has always been they struggle when they actually move from lab to being a company, primarily because they lose access to the labs within the universities. So one of the key features or functions that we created within National Grid is we actually set up our facilities within the Create building to actually have this shared lab facility where startups, including biomanufacturing startups, can actually explore leveraging shared resources to actually start their scale-up process. So it's not just a space. What is a USP for this National Grid Labs is that we actually offer access to high-value NUS and NTU equipment. So if there's a bioreactor that's high value in some NUS lab, that's something that the startups can actually access through membership within the National Grid Labs. So I think we are helping in that journey, and that I think is a core need within the infrastructure area.
Raymond, anything to
Yes. So actually, Kyoto University has a similar setup with NUS in that we bridge entrepreneurs, founders with researchers. And by the way, we have a formal collaboration with NUS Enterprise. So they have we have a GRIP program, a GRIP Japan program, where Kyoto University has sent 3 startups to be incubated there. So yes, I concur. So I think in my mind, there are 2 primary obstacles. One is as you said, the infrastructure, giving access basically to both researchers and entrepreneurs to commercialize the research. But I think personally, it's not a huge hurdle. The bigger hurdle is really identify, because lab research is more theoretical. It takes a long time to identify what actually, which kind of research and technology could resolve problems and potential and has potential to scale. So identifying the research, which you need both very deep technical and business acumen. And third, okay, there's a third point, connections, human connections. So both sides may not know the right people in each other's ecosystem. So, and nobody knows actually. So it takes like NUS Enterprise, maybe Kyoto University, to bridge the gap. And the people who bridge the gap also has to have a very macro view of both ecosystems in order to do their jobs well. So I think these 3 points are obstacles, in my opinion, here.
So particularly, I think something that all three brought up is the part on shared infrastructure. And actually there is already being built around, there's access for people to go. Universities are actually putting effort, or maybe national initiatives are putting in effort to build this shared infrastructure for universities to actually overcome this bottleneck in scale up, if I'm right. So I think now moving on to other than infrastructure, sometimes even with the best infrastructure, the best toolkit, translation fails because you don't have people that speak both of the science and the business. So moving on to the talent portion, what skills are most lacking when transitioning deep tech or research teams to commercially focused biomanufacturing organizations, in your opinion? Maybe I start with JD on this question.
Well,
What skills are most lacking?
I would say, looking through the many teams that I've seen within National Grid, and I think this is common knowledge, most startups would need at least 2 kind of roles. They would need a hacker, someone who can actually hack out a solution, and a hustler. Well, I would assume that all co-founders have that hustling ability, and that's something that I think is very, very important at the very earliest stage, while they kind of figure out this, where exactly their product market fit would be. And then once that at least some form of product market fit exists, then it's having the right connections, and that may actually take an additional co-founder who have the network within that industry to actually do that scale up in terms of commercialization as well. So that's something that we see recurringly.
Any thoughts from Raymond? Yes.
Skills, right?
Yeah.
Yes, ideally, basically, people involved with research, tech commercialization need to have both technical and business acumen. But in the greater scheme of things, such talents are vanishingly small. It's very unrealistic to expect to hire only such people. So I think, I heard an analogy recently. Any team, especially in this case, right, it's like a football team. You know, you have the defender, you have the goalkeeper, you have the striker. Each person has to play its own role, no matter how small or what they think is small, because each builds up and compounds. So personally, I'm from the finance side, investment side. I'm not a technical person, like scientific person, but I play a role because my technical DD, investors, they are very adept with the science, but they may not have, say, the breadth of knowledge or experience or the connections required. So we complement each other. It's impossible. You cannot, I think in the sense, there's an ideal type of talent, but you can only get what you can get.
Yep.
And then you encourage collaboration, not silo thinking. You encourage them to resolve problems. So it has to be a more outcome and basic outcome and problem solving basic oriented approach in managing teams. Yeah.
I see. Prof. Choi, any thought?
I think the most important skills is kind of interdisciplinary skills to cover biology and engineering. Yeah? And also, we need someone who has a very strong leadership to bridge the gap between the biology and engineering, because in many cases, based on my hands-on experience, these 2 groups are not communicating very well, yeah, and they have their own, target. So we need someone who has the overview and the capability to bridge them for the best performance.
Yep.
Yeah.
So it seems like there are a few ways of thinking about it, because universities can train scientists to be more business facing. But like what Raymond says, sometimes it's impossible to do that. So actually you then have a team where people specialize in what you have, and then you work as a team or a mediator to, like what Prof. Choi mentioned, to be able to bridge the two sides. So we looked a little bit at technical, a little bit at talent. The last area that we want to look at is on the fuel for all this, and that is on the capital side. So a lot of times, pilot and demo capacity is expensive and risky, but it is essential to de-risk on the scale-up to attract customers. So the question I have on the fuels, on the capital side, is given the high capital requirements for pilot and demonstration scale, how should the risk be shared between universities, government, industry, and investors? Maybe I invite Raymond to give your first thoughts about this. How should risk be shared?
I think there's no definite answer. It depends on the situation. Each university or organizer has its own approach. So what I can tell a bit from Kyoto University's approach. So Kyoto University is a public university, meaning it gets its funding from the national government, especially the Ministry of Education, Science and Technology, MEXT. If you're talking about POC, pilot projects, that's not commercial. Well, it depends though. So it may or may not be financed by investors. Sometimes they are just too early for VCs or even angel investors or seed investors. So they have to be funded by grants. Grants would have to come from the university or the government, like public universities as well. Like NUS is similar.
Yep.
And then we have different types of grants as well. So we have the research grants, of course, pure research,
yep.
but they don't cover commercial. They are not allowed to cover pre-spin-offs, those who are looking to commercialize, right? Not translational research.
Yep.
Then to cover that, we have something called the GAP fund.
Yep.
GAP fund. So it's a very specialized kind of funding, grant funding, usually from the government. So in Kyoto University, it's from the university and the government. Interestingly, some of them are from the private sector. They give as donations or part of their CSR to be created as a GAP fund for Kyoto University pre-spin-offs. And so VCs will only invest when there's a firm market validation, when there is a product, or at least they have an idea what the product is, and it's usually from seed. So every step of the way, there are many different funds, many different steps, and different skill sets required to handle all these situations.
Yeah.
Maybe I can add to that. So as part of the value proposition that my colleagues who are venture architects within the GRIP team at NUS Enterprise, of the various value propositions, one of the very key ones is actually to leverage on this gap funding that Raymond was talking about. So for example, within our team in the last, I would say 6 months, we've actually closed 3 different projects of up to $10 million in value that has been able to help these pre-startup teams explore commercialization and figure out what are the gaps that are needed. So of course, these are not from the university directly, they're from the government directly through NRF. But that's something that we leverage on effectively to help startups actually explore that process.
I think university and government are very close to each other. So, and there are many funds available to establish those kind of infrastructure. But from external grant, there are very limited, scope from the external grant for us to establish such an infrastructure. So the major, funding probably comes from the university internal funding to establish it. And industry perspective, assuming our customer is mainly in the chemical sector, the chemical company, they don't have such an infrastructure for bio processing. So university had better establish such a platform for industry partner to access it, and then they can validate whatever their achievement in the lab scale. So internal funding from university is one of the key, resources, and then the industry can access to it by payment basis. That is a ideal practical operating system.
Yeah. So I think that to sum up this part on capital is really for innovation. There's a lot of grants, and government can take on that risk when it's very early stage, universities and governments. But when it crosses a certain area where it goes into commercialization and scale up, that's where the industry should come in and take on that risk, because ultimately they will be the off-taker of the product and things like that. So just out of curiosity, this is not in my list of questions, with all the different areas of applications in biomanufacturing, from looking at the universities, which are the most promising application areas do you all see from what is coming out from the universities in biomanufacturing? Application areas like chemicals, food agri, what are your views?
University, there is no limitation in terms of application. The university professor can do whatever they want to do. There is no limitation. But the issue is whether it is commercially feasible or not. So many of them get the grant from certain the partner, and then they focus on the scientific discovery and achievement without any concept for the commercial feasibility. So it's their freedom of operation. But for certain project, when they are working with industry partner, the situation is different. So industry has their own problem statement, and that concept has to be reflected in the early beginning of the project. Then they already start the project with commercial perspective. So it depends on the project type and who invest. So university has many operating freedom.
I'll share that as a very strong AI advocate. I think it would be remiss for us not to even highlight the combination of leveraging AI in biomanufacturing. I think we actually have a team in National Grid that is actually doing that as well. So it's really exciting and interesting. I think we are at that day and age where AI can really be productive now.
Right. Also AI and biomanufacturing and blending that two together.
Yes. Yeah. Very exciting.
And riding the AI wave, actually. Cool. Raymond?
So building upon what JD and Professor said, so how do I say? It's not about what kind of research is promising, but rather what are the problems that should be solved that can be solved using university research, and which research? How do you commercialize? How do you realize those research? So I think it should be a more solutions-based sort of orientation, so to speak. But okay, on AI is everywhere now. It just makes, it's not an end game. It's not its own vertical. It's just a way to make productivity increase by many, many multiples.
Yeah.
So real case study is that so iCAP has a portfolio company called QLux. It's not a bio manufacturing company, it's a chemicals company. So they make very special powders for high resolution monitors and display panels. They are the only ones in the world who has created this basically a dark blue powder. It seems, but it's actually the only ones in the world. They're the only ones who are doing that. But okay, so that's the sort of the very cutting edge work that they're doing. They also have a not side business, like they have a platform. Yep. We call it an AI chemicals discovery platform. So it can simulate combinations of millions of chemicals. Yep. It has its own revenue already, even though the cutting edge stuff is not commercialized, but it's in the midst of being commercialized. That AI platform, which it's used to its own research, it's also used to service big clients like Korean display manufacturers, for example.
Right.
So that is, I think it's a very good example of basically using AI embedded in the research. And plus, it's not incubated in Kyoto, it's from Kyushu University, that's a Q Clux. So we went in as a pure investor.
Right.
And I'm glad to see that they are doing well in that regard.
Awesome.
Okay, also, we have an LG manufacturer. Not one type LG, but a library of LGs. So they don't, again, because it's solutions-based, right? So they are not targeting biofuels because the margins are too low. So they are looking at more premium wellness medicines off the shelf, over-the-counter medicines.
Right.
So yeah, it's solutions-based, using AI to increase productivity and potentially get revenue on its own.
So it's a platform technology, but it solves a different problem.
Correct.
Yeah, so
solves many problems, actually.
Yes,
Yeah.
that's the area. So I'm conscious about time and understand that there are also multiple appointments after this. So I just want to bring this conversation to a close and maybe give a more regional perspective. So APAC is actually a very diverse region. And I wanted to just pick your advice, and the last part here is, what is your advice for us to build a cohesive regional ecosystem for biomanufacturing?
Yeah, let me
Yes, think
do the
about it.
first.
Yes.
I think this is very similar to Singapore's petrochem industry planning and operation. So Singapore has no petroleum as a feedstock, but we have very well-established petrochem sectors established in Jurong Island, which is one of the, I think, the world's third largest refinery facility. So we can also adopt this same business model for biomanufacturing. We don't have many biomass available as a feedstock, but we can we can treat the biomass, in other area in our region, and then we get certain intermediate to bring to the Singapore, and we process further to make another intermediate along the value chain, and then we can provide the final customer and user. That is something the best, practice model, considering our existing infrastructure and manpower capability.
Yeah, I echo that certainly. There are many startups, teams that we incubate that explore, because of space limitation, they will explore manufacturing in, let's say, the region, and leveraging on IP here in Singapore. So, and of course, also talking about formal collaboration and partnerships between different universities. I think that actually helps strengthen that inter-ecosystem collaboration and encourage us to actually leverage on resources for the greater good.
Yep.
Diversity is strength. So APAC, yes, very diverse, but each of them has its own strengths and weaknesses. So just to keep it short, I mean, going back to my analogy of a football team. So for example, biomanufacturing, right? You can do your R&D in Japan, Taiwan, Korea, have your BD and fundraising hub in Singapore, maybe downstream operations like manufacturing Thailand and Malaysia, POC again in Singapore, market venture, basic market development in Japan and the US, for example, because they're big markets.
Yes.
So I forgot to mention the captain. Captain of football is very important. So this goes back to what the professor said. Leadership is very important. So the leader has to make sure all the wheels, all the cogs, all the wheels in the machine run perfectly. Thank you.
Wonderful. So what we really want to do with all this perspective is how to build a win-win situation for every country in the region and beyond globally, so that we all be able to benefit from biomanufacturing as an industry as a whole. So please join me in thanking our panelists for today. I hope you all enjoy this panel. And also, if you'd like to get connected with them or myself to continue discussing this topic, feel free to approach us anytime after this. Thank you very much.